There are various ways how you can apply the Weather API to the specific needs in your industry. For example, given you're working in the rail industry and you want to have a knowledge about the impact of temperature, precipitation, maybe on power lines or so, on the rail network in general. In our API, you can easily query different types of parameters. So for example, when we just go to the basic parameters, say we can query temperature within the API. So we have the general structure, again, api.meteomatics.com, the timestamp, and the granularity of 3 hours, the temperature over here, and then the geographic coordinates. What you can do then is to combine that knowledge with your industry. So for example, temperature is pretty important parameter for network rail. You can add, for example, the precipitation. Say the precipitation within 1 hour. So I just changed the granularity to 1 hour as well to be consistent. And as well, the type of precipitation might be pretty important as well. So precipitation types can vary. We can also change the location, which means along a rail, you might be interested in line forecasts. So for example, when you have a look at our coordinate description, there's a line parameter. So you specify the start point, the end point, and the number of points. For example, we can choose this one displayed over here, and we replace the coordinates or the current coordinates with the information of the geographic location. In addition, we changed the format to CSV because it's easier to see that in a CSV file. So we do have the temperature, precipitation, and the precipitation type along a route which goes from 15-50-10 to 50-20. If we hit enter, the API queries the data in a very fast amount of time. Now we could add another parameter. For example, if we want to know the impact of snow and ice, for example. So we have a derived parameter that is called the power line oscillation warning. So for example, when you have precipitation in the form of freezing rain or wet snow, that can freeze up power lines. So we just use this power line oscillation parameter over here and copy that one directly into the request of the API. And we hit enter, and there's a new column appearing. In this case, 0 means there's no warning active, which is good, and that's what we want in the rail industry. You can change also the date time. For example, if you're interested in winter months, for example, you can go back in time, say you select a day in January, and then maybe change even the locations a bit and see if there was a different type of precipitation maybe, or just more precipitation. You can query that pretty much for every location, for every line, as you wish, and you see the data displayed over here. So what we did is querying the temperature, precipitation type, and a parameter called power line oscillation along a route or along a line, which is 5110 to 5220 with 100 points in between. So you can modify that for your track as well and customize your own API query. The data can not only display it as a single line, but also onto a map. And this is something I would like to show you within the next couple of minutes. So for example, given we have the American mainland over here, we can add a layer and we can choose between a variety of sources. For example, we can choose from the ECMWF IFS model, or for example from the NSAP GFS model. In this case, I go with the ECMWF IFS model and select the effective cloud cover for now. I hit OK, and then I can display the weather data just straight onto a map. For example, we can add also another parameter. Say we take the precipitation within 1 hour and click on OK, and then we see the precipitation displayed over America. So you can add a variety of layers. For example, if we remove this for the moment, we can add lightning data, radar data. We can add also station data, for example. We ingest all kinds of observations from American weather stations or global weather stations around the world. So if I hit the station data, you can see all the stations displayed onto a map. And you can even say filter these regions or filter these station data, for example. In that case, we go for, say, 10 degrees to 20 degrees. And then we can display everything between 10 and 20 degrees, for example. Another capability of the API is to display like a huge amount of different kinds of weather data and combine them into one map. So, for example, you can choose between the style of ISO lines and display weather data such as the wind speed, or, for example, the geopotential, the theta E maps onto like a screen like that. Or if you want to be a bit more advanced, you can even go through a panel overview of up to 4 panels, where you can specify different kinds of weather maps. Say you can investigate the entire weather pattern over Europe or over the US if you are interested in. And you can also generate plots, like the plots we saw before, but we can add a few more features. For example, in the case of New York, we can look up this location, and it is displayed onto the plot in our MatX tool. We can also add a threshold here. So say if we are interested in, say, the temperature at 2 meters height, we can say, okay, we would like to have the temperature to be displayed in red if the temperature goes below 10 degrees. So I just type in 10 here, and then we see a red pattern for all the temperatures below 10 degrees Celsius. You can add way more layers, or you can even add new plots, for example, not only for New York, but also for other locations in the world. For example, take Berlin in Germany, and it's displayed as well. You can add another location, say, which is very far away, say Sydney in Australia. So type Sydney here. And another city that could be, for example, say Cape Town in South Africa. So you have the temperature and the cloud cover in that case displayed for multiple stations around the world. Now I want to show you the real power of the API, and for that I will use the visualization tool Cesium. And over here I display the temperature at 2 meters height in degrees Celsius. So the real strength of our API is that we have a digital terrain model from NASA included, which means we can downscale the data up down to 90 meters. So traditional models will work with a very coarse resolution. For example, the Rocky Mountains, which are displayed over here, like I just focus on down to Colorado, maybe close to Denver and Boulder. You see a very nice structure of the entire mountains over there. And on the left-hand side is the downscaled data, and on the right-hand side is the data from the GFS model, which has naturally a resolution of up to 20 kilometers. So if we swipe over here, you see that all these fine structures of the mountains suddenly disappear. So in the coarse model, you can't really resolve the mountains and the depressions. But if you choose the Meteomatics model, we downscale the data down to 90 meters, and you see all the fine structure of the mountains in a very great amount of detail.